Well, hello. Welcome back. Friday afternoon, 6 o'clock, Abu Dhabi. And we're back for another session. If you're joining online today, welcome. Oh, and I see I forgot to change my background so the lights will look a little bit bright. Let me change that quickly. Let me settle that down and get the room ready. It's been a bit of a rush, I must say, today. I have not been able to finish everything I planned on. But and yes, we have to keep going. Even my plants are suffering. I'm giving them no attention recently. Tomatoes need to be taken off and water needs to be replaced. So hydroponic system is looking a little bit bleak. That's okay, we'll get to that soon. It is weekend, and even though I haven't had that much time to prepare everything, and I've had quite an evening with my other printers trying to get it up and running just to build some pieces, but I'm happy that we can carry on. You're not seeing a printer in front of me tonight, so what happened? Well, there's some things that I still want to do on the printer and get ready before we get back to the printer and start doing cabling. But before we get there, one of the things that you need to sort of do, and what they recommend, is to get your main board and your Raspberry Pi and all that set up. So this is where, unfortunately, the wheels comes off a little bit with a lot of people trying to do custom printers. They enjoy the build. Get to this point, when it gets to the electronics, it's too difficult and they lose interest in the project. So this is the tough part of the project. Now it really gets hard, because putting the printer together is not really that challenging. You just follow the documentation as best possible, and most of it's logical. But when it comes to the electrical side of it, the software, I sat until 2 o'clock this morning trying to resolve a clipper issue, and I just couldn't figure it out. I mean, she went to bed, and thank goodness this morning when I woke up, I had a bright idea and came back and was able to resolve it. But if you're not into this part, if this is the part that's going to break you, then I would recommend that you actually go with a printer that's pre-configured, one that's easier. The Pruses, the Bamboo Labs, Creality K1s, Snap Makers, and all these things. And you shop around. I'm not going to say which one you should go with. I think the market speaks for itself. But if you can get through this portion, oh my goodness, we have a visitor again. If you can get through this tonight, and it's you're enjoying doing this, well, then you're in the right space, because this is what we do. This is when it comes to printers and building your own printer. This really is part of the enjoyment of being able to configure it and set it up the way you want to. So I'm going to have to get rid of this mister, because he's not going to leave me alone all night. I just don't know what I'm going to do with him, because he's going to want to be around the whole time. So yeah, if you see a cat up on top of everything, he's part of the stream. He's well known already. Hopefully he'll settle down over there, and but I doubt it. He'll be up and down the table. Okay, so first things first. Let's move over to a new web page, right? And in this document, and I've changed the camera angles tonight. So tonight we will have a bit of a top view from a little bit closer, and a side view from really up close, so that I can give you some more details as I'm going along, and you can see a little bit more. But as in general, we're going to come to our, not that one. That's definitely not what we want. We definitely want that one. But to keep it interesting, I'll just keep it like that and you can see me. So, RatOS. What is RatOS? I'm going to summarize this and I hope Mikkel will forgive me for any mistakes that I make. Mikkel Schmidt is predominantly the person that maintains and developed RatOS. What is RatOS? It is a version of Clipper. And Clipper with Moonraker and Mainsail and Clipper Scream all bundled up in a nice package and shipped out on the web so that you can read, download and install. Much like the consumer printers that are out there, that where the market's trying to move to, plug and play, just put it down and print. Much like the Bamboo Lab and the K1 are achieving. The community that's building bigger printers now really want to be able to also move forward. And so, as I said, this piece becomes a little bit harder, and to really get into the Linux and drill down and do all the commands, and that becomes very difficult for certain people. And if you're not used to it, well, it's going to be a challenge. I still suffer in the Linux environment. It's not something I'm comfortable with, but over time I've learned a couple of commands. I've learned to copy paste a lot. But what RatOS has done is they've just packaged this thing nicely, and it will help you deploy your software onto the actual Raspberry Pi and get your board up and running. Now, he's going to explain how it works and what do you need. I am going to be installing it on a Raspberry Pi 4B. Hence, I had lots of problem with the other computer last night, because Raspberry Pi 4s in some parts of the world are very difficult to find. Oh, we got them here in the UAE. We can find them. It's just the price that we pay for them is exorbitant. It's really expensive. So what I've been doing lately is I've been getting my hands on some of these. These are called Wise dumb terminals, Wise 3040 terminals, right? And pretty much what's inside here is what's inside here. It's a small SBC computer. It's a small base computer, but in this one, you're going to have to learn to. You're really going to have to learn to do Linux, and it can be very frustrating because you need to understand Debian Linux, and you need to be able to deploy different config files and set up your Wi-Fi in Linux and command line, and so it becomes so much more challenging. It works. This thing works a dream. My Voron's running on one of these, and I can't complain with the Voron running on this thing. Performance, it's just brilliant. There are videos on this, how to set this up on the internet, and you don't have to use this. There's other small base computers. Orange Pi is one of those that I can just think of. It now. Rock 32, I think, is the other one. Yes, they're all there. But RatOS is really focused on Raspberry Pi, because that was always been the industry standard for 3D printers. It just makes it easier and with Clipper. So I'm using the 4B. I have a Raspberry Pi 3, but I just decided I would rather prefer, if I'm going to use the latest printer, I want the latest Raspberry and I want the maximum speed out of it. So then they're also going to say which printers they support. Pretty much V-Core3, V-Core Pro, Minion. And then they've started expanding out in experimental Voron V1s and Prusas. I think that's amazing, because running a Prusa on Clipper would be quite interesting. Then it's just about contributions and credits. But let's get to the installation. So maybe I can just go back one step before we get there. Remember, there's three versions of three derivatives, or can I say operating systems out there that you can use on your printer, and one is Marlin, one is RepRap, the other one is Clipper. And most printers started out with Marlin, and Marlin still exists and it's still pretty much good platform, constantly being developed. RepRap is more is also a very good platform. It actually I went to RepRap before I went to Clipper, simply because of advanced pressure and can I say the amount of calibration I could do on advanced pressure management. Yeah, and I ran it on a Duet motherboard, which is slightly different to this board, and it was really good. But then I discovered Clipper, and to me Clipper's at the moment the way to go. It's the only way to go. So I put Clipper onto everything else to remove everything else that I had, and I've just been full on Clipper ever since. Even on my Creality CR10 Pro, it's running a Big Tree Tech board, SKR3. What is left of the Creality in my Creality printer will probably just a little bit of aluminium, because I'm no longer on V rails. I'm on linear rails. I'm got a new bed. Came with a 24 volt heater bed. It's got a 220 volt Kanobo heated. So it's just pretty much, I call it the not so Creality machine because it's totally different. And yeah, it just, when I put Clip on that, I got such amazing results. So just the way to go. Okay. So getting to the installation, maybe what I'm going to do before I get to the installation is just drop down here to supported boards. And I want to just touch base on the supported boards first. You'll see from RatOS perspective, it's predominantly Big Tree Tech boards that they're supporting, with a bit of Fazek and a bit of Prusa boards, right? Again, if you've got the skills, you can run this RatOS on any board, but you're going to need to know how to configure the software and the configuration of the printer in the printer file to your board. Meaning, each one of these little connectors have different pinouts on the board, pinout numbers, and in the configuration you'll see later on we'll see different pins that need to be adjusted in order to get the board to work. So that your stepper motors, when it talks to the Z stepper motor, it's the Z stepper motor. When it talks to the extruder, it's the extruder, and it's actually, when it's talking to when it's reading one of the thermometers or thermistors, it's reading the correct thermistor. So you've got to tell the board where did you connect it, right? And that's what RatOS has also done. They've tried to take the most common boards used in the market, and they are I'm not showing you actually what I'm looking at, so maybe that would help. They give you a list of all the different boards that they pre-configured, right? There's, as I said, the Fazek and the Prusa. Again, all these aren't the only boards, but these are probably the most popular boards at the moment in most of the community, because Big Tree Tech is really strong in that. I know there's lots of other people that use other boards, but I just stick to them. It's easier to deal with a board that everybody else is going. In my other printer at the moment, I've got the SKR3EZ, and I'm post this RatRig build, I'm going to actually convert that also to a RatOS and run it on my not so Creality Cartesian type printer, and we'll see how that goes. This board that I have over here, and let's just quickly zoom in onto this board. You're not going to see this board there. This is one of their newer boards. This is an Octopus Max EZ version 1. Right, now pretty much what does EZ mean? EZ has got to do with the way that the drivers are plugged in. Big Tree Tech have come up with a new way to actually plug the drivers in. Previously it was like little pins that you used to push in. You'll see it on different boards, and I am using this one. So let me just have a look have I got one of those drivers close by? I can quickly show you. Yes. Let's take this one here. So this is a motor driver, and there's different variations of the drivers. Again, 90% of us use the 2209 driver. We use it on many different machines. So let me go and put it like this. That is what a driver looks like, right? It's a little board, pretty much got a 2209 processor driver on it, and it used to be pins like these pins are, you know, and they've now changed it into this format so that it's very easy. You just decide where you want to put it in, and let's say I'm going to put it in on the first one. It can, if you try and put it in the wrong direction, it won't go in. It doesn't. It has to be in the right direction. That's one of the beauties of the new format, because people were putting it in the wrong way and blowing it up. So if I turn it around and I push it, there it goes in, and that's it. Simple. I can't bend the pins anymore. It's got a heat sink already built onto it nicely. It stands up. We can blow air across it. Works very well. Okay, so that's the Octopus Max EZ. So now let's go back to the screen. Octopus Pro, oh my goodness, it's not here. Okay, yes. RatOS doesn't officially support the Max EZ board yet. Every day I come here with the hope that I see it. And I was hoping it would be here beforehand, but it isn't. But I know that the Max EZ board is pretty much the same as the Octopus Pro, and this does have the H723 chipset on it, right? So we're going to sort of need to customize a little bit of this and see where it goes. Now, whether I should have used the version 1.0 or the version 1.1, it doesn't really matter too much from a chip perspective. I'm just going to try and get the camera in the right place here. Got to learn which way to go now. Okay. Anyways, there you go. That process over there is the same. What differs is the actual board, the board version, and that board version we got to try and might have one or two different changes in terms of how the processor connects to some of the features on the board, which is fine. So I'm going to follow the guide to the point, and then I'm going to have to sit down and go through very methodically through the configuration document to make sure that according to this board's documentation, the pinouts on this board are the same as the pinouts in the configuration that I'll be using by default, before I actually start connecting all the devices and the motors and the thermistors and everything that are around. I just want to make sure it's 100% working. Going back to, I think it was under the installation page. Or maybe in the somewhere, and I can't remember exactly where. Can't see it. Oh, here it is. This is what I want to do. They actually recommend flashing your board and getting your board ready before pushing any of your devices, like your motors and your even your drivers. You can flash it beforehand, right? So you can flash this whole board before connecting anything, and hence why I want to flash it here on the table tonight, so that I can make sure it's working 100% before I get it into the housing and it's all ready, and then I can't get that right and I have to disconnect everything and then I have to play around. It's easier to play with it on the table over here while I'm working. Okay. So first things first, we need to install basically RatOS, which is the Clipper, which is the Raspberry and software, which is a Linux kernel, the Clipper, the Moonraker, and the main cell. Those 4 items need to be installed. And so to do that, as I said, they've made it easy. All we need to do is go to this website. Just take note, if you're using a Raspberry Pi with 1 gig or less memory, we must use a 32-bit. Otherwise, we're going to use a 64-bit. This is a 4 gig, so we're good to use the 64. We'll go ahead with that. If we click on this link, it will take us to a page where we can then see all the downloads. And as you can see, there are images for the CB1, which is it's a derivative of the Raspberry Pi. Basically, it's the Raspberry Pi just in a very small board that plugs into a host board, right? But we haven't got a CB1. Yeah, we can see Raspberry Pis. These are 32s, and we go along. Yeah, we got the 64s, and over here is the image XZ that we need. It's about 1.4 gigs worth of download, right? So I wasn't going to take a chance this evening, and I thought to myself, hold on, what happens if the download doesn't work? So I've already pushed the button and I've already downloaded that file, because it's quite a large file. Downloaded in 2-3 minutes. Didn't take that long, luckily for me. Going back to the browser. The next thing that they're going to tell us to download also is I don't know how to pronounce this. Balena Etcher. That's how I mention it. So if we click on the Balena Etcher, let's just close these other two in the background. This is a software that is used to write that image to a SD card, and we're going to download this now. Just accept that, and we're going to put it on a Windows 64. I want to do the installer. You can do portable if you want. It's not serious, or depending on whatever you're using. I'm using the installer. Right, you can see it downloading over there quickly. Shouldn't take more than a minute, even 30 seconds, hopefully. And there we go. Right, then it's in the downloads. I'm going to go back to the Explorer, and I'm now going to run this program. Now, you probably won't see everything that I'm doing. As soon as I get into the installer, I'll try and switch to it. But typically, you're just going to run through the installer. Let's see. No, I can't show you the installer unless I share my whole screen. Alright, so I'm just going to go through the installer. It's pretty much agree. The first button just allows you to push agree, and then it starts running a installing please wait. It's as simple as that. There's really nothing to this installer. Right, and it's finished. I'm just going to launch that app in the background. Let's see if we can open up this app. As soon as the app opens, hopefully I can show you what I'm doing. If I had two separate screens, I would have welcomely shown you my whole screen, but unfortunately I'm running off a single wide screen, so it's a little bit difficult to only share a certain section unless there's somewhere in the browser that I can do it. I'll have a look for next time. Let's see if it'll allow me to switch to this app. Hello wife, how are you doing? Hope Ariana's doing okay. My daughter just had braces put on this afternoon, so we're quite happy that she did well. Very happy, very proud of her. Okay, I'm just going to try and see if I can find a way, give me a second, to see if I can share this portion of my screen somehow, because I'm not able to show you what I'm doing, and that really I thought it was going to allow me to show you. Okay, let's just do that. Well, that didn't work, so that just threw us out totally. Okay, let's see if I do the following. Part of streaming, you know, gotta try and figure it out still. Let's go back here. There it is. Got it. It's just a little bit small, so let's stretch it across your screen. You can see a bit better. We'll just center it. All right, so what are we going to do here? First of all, we need to have a SD card, right? Now I'm using a SD card, a 32 gig SD card, and it's, oh, I haven't got the autofocus on there. It's a ultra high speed card, which is pretty important. Buy a decent quality card if you can. And I'm going to put this into my card reader. Right, and I am then going to flash from a file. It's now prompting me for which file, so that file that we downloaded, I'm going to open up that file. Okay, I've selected that file, there it is. It's going to ask me to select a target, and we've got this generic file. That's interesting, the other hard drive. Okay, so install to the flash drive, select, and that's it. Flash. That's as complex as it gets to put. Whoops, it's asking me for some rights. Mr. Fig. All good that side? Okay, while it's busy with that, just coming back to this box and doing this, I would have naturally had to install Linux separately, as I said. On this one, there's a video that you can Google or go to YouTube and just watch. It basically takes you through a Debian installation, and then it shows you how to install Clipper from the command line and get you up and running. I'm not going to say shockingly difficult, but not easy as well, because when there's something goes wrong, and there are one or two little tricks that I had to learn with this box to get it working properly, but it is possible. So if you can't get Raspberry Pi, or you feel you want to try something, you can even run Clipper from a laptop if you want. You know, it just needs a USB connection to the main board, right? And we connect the Raspberry Pi to the mainboard via USB. So while that's running, I'm going to, in the background, start getting some things ready. Now, just for interest, let's show. I printed this housing today. It's a draft housing, so I printed it very fast, just to see if the sizing works and what it looks like and how it would work. And essentially what I'm going to be doing is mounting this board with the power showing that way on the mounts over there. And I'm going to be mounting this Raspberry Pi like that with my connections on the outside and those pointing up. And so I can get to everything easily. The only item that's a bit tough to get to is that USB port. So hence why I wanted to print it. I want to see if it's something that's going to hinder me, and can I get around it, or do I have to redesign this bracket myself? What comes on top of this is another printed part and then two 120mm fans, because fans can just blow straight down onto this. I previously had a heatsink on this Raspberry Pi, and I would have actually liked to keep the heatsink on the Raspberry Pi, but the problem with that is the holes come from the bottom, and for this mount the holes need to come from the top. Now, I don't need access to any of these other ports, and as you can see, this pushes against little little heat transferring pads, and that helps just transfer the heat into the block, and then you'll have a fan from the top blowing on it. So I'm going to think about how I could possibly even change this thing a little bit to accommodate that. And I think there's about 2 or 3 different ways I can possibly accommodate that, which would give me that ability to keep that heat sink on top and allow the heat to distribute well. So we'll have a look, but that's for a thought later on. I just want to quickly push a message here. Everything's still there. Music just stops so suddenly while we're waiting for this flash to go through still. It's got a couple of minutes to go still, so let me quickly just want to go in here. I forgot to share the link, and so I just wanted to quickly share this link for the stream because I was asked to do it and I never did. My bad. Yeah. Okay. And Mr. Figs asking. Okay. Got to keep the phone on. Remember what happened a couple of weeks ago when the lapel mic died? So people at least watching now. If lapel mic dies, they can phone me. While it's going, I can also talk about other items. So I need to get a power supply running. Well, in the meantime, the Raspberry Pi I'm just going to power with just a normal Raspberry power supply. I'll just plug it in on the side and we'll take it from there. For now, while this is not in a housing, I'm going to put this back on, and I'm just going to put the housing back in, and it's just easier for me to handle it. That way I can't drop and short anything on it, and it's just neater that way for now. Not even going to tighten it that much because it just needs to be touching both sides. Okay, right, so there's that. We'll plug the USB power in as soon as we're finished with flashing the software. So the flash is still, it's still going there. You can see we're about 48% now. Very horrible color that they used. But in the meantime, let's come back to this over here. So part of the build, we need a power supply, right? I'm going to be using a LRS 350, a 350 watt power supply, because I had one, and the one that I received with RatRig was a 300 watt power supply, but without a fan. I plan to add a couple of more devices to the printer than what the normal person would. So because of that, I'm going to use the stronger power supply with the hope that I don't damage anything. Then I've got a second power supply, and because I don't want to use the Raspberry Pi plug the whole time, it's all got to be plugged in, I'm going to power the Raspberry Pi from a second power adapter. And why do I want two separate power adapters? Because I want to be able to switch off the printer head and everything else on the printer, kill the power. But I want to be able to keep my Raspberry Pi up and running so that I can shut it down safely, and I can work on the Raspberry Pi without having to switch on the whole printer. So you'll see a lot of people building printers that actually have a separate power supply, a 5-volt supply going to the Raspberry Pi. Okay. Hence, I will be putting in my power with a fuse, with the power for the main board or the Raspberry Pi I'll put on here, maybe I'll see. I'll decide which one, and then one additional switch that will come in, and that will be for the main controller board and the rest of the electronics inside the enclosure. You know, some bug come and land and mess up my table. All right. Part of that is also I will be using Wago connectors. These connectors are just there to help me do some wire management going back and forth. I will be using, obviously you need to use one SSR, which is your relay, your solid state relay, that you use to power your heater board, right? So on the heater board, we have 220 volts. So from the main board to the SSR, we got 24 volts coming in, right? Which switches the 220 volts on and off to control the heater pad. Now you might be in the US or somewhere else where you use 110 volts. The model I'm using over here can handle anything from 24 volts to 240 volts AC. I bought these separate. I think you can, part of the set, you can order the sealants that come with. I decided I want to buy Omrons from Omron directly, so I bought Omron SSRs. We'll see how that goes. I've got a couple of those. Why have I got two? Well, because I'm going to do active heating in my chamber. I've got these PTC heaters, and these PTC heaters are 220 volt PTC heaters. So the fan and the heater itself is 220 volts. So I only need to supply 220 volts there. But to switch this on and off, I can't connect that directly to the main board. So I will be connecting this side to the main board on one of the controllers there to switch it on and off, so I can control the fans. There will be a thermometer, a thermistor sitting somewhere in the actual printer, measuring the heat inside the chamber, and then the whole system will switch the SSR on, which will switch on these heaters, and it'll warm up the system. And then when it reaches a certain temperature, the SSR will switch off, which will then directly kill the power on the PTC heater. Because it's such a large unit, because it's a 500, I'm going to be putting 2 PTC heaters. That's not standard. That's totally different, separate to what most people do. I'm actually quite interested. Will probably only do that later on, but I'm actually quite interested to see how much heat the 1500 watt bed actually creates and how well it keeps the chamber warm once it's up to temperature. So this will probably be used only to get the chamber up to temperature, like on the Voron V0. This PTC heater comes on once in a while. Mostly the heater pad and the bed keep the chamber warm, but to get it there, this helps a lot. Otherwise it takes forever. And then the other thing is I will be putting LED lights in so that I can see inside the actual enclosure properly. These are just added features. Again, you make your printer your own. We're at 85%. Some of the other stuff that I've been doing this week is on the back of the printer. You would have seen that spine that goes down where you can put little clips and you can run all your wiring. Well, I decided I wanted to go with something different. I'm going to use that. I'm not going to buy channeling, I'm going to print channeling. So I pulled a design off printables. It was only a short little design, and I expanded it up to this length, and I'm probably going to print another set length. So somewhere along the line I'll release this on printables if anybody wants it, for the longer version. These clips, unlike the one that's on the RatRig, those clips come off. These ones you can flap open and you can get your cables, and then you can close, and then you just clamp them closed when you're finished. Very nice, very easy to use, nice system. And then mounting all the items on the printer, I've cut DIN rails. I have printed these ends specifically to hold the DIN rail, and it's got a hole on either side, and I can just bolt that in. Now the DIN rail will sit behind many of the devices, right? Why do I want to have the DIN rails in? If something breaks or something needs to be changed, it's much easier if you've got DIN rails, to be able to take your parts out of the printer and then replace them and put them back. If you double-sided tape them and screw them down, it becomes very challenging to remove items, and it just helps a lot, and it looks a lot neater as well. So on the bottom of all of these power supplies, there are little holes, and I've also printed connectors, right, which will help connect that to the actual DIN rail, and that's how it looks. It'll sit like that roughly. Now there's different size DIN rails, connectors, and I'm going to be designing as I'm going along and changing some of them and making them purpose-built for my project. On the back of the bigger power supply, they have a much beefier type of housing, so it will be 2 of these stuck, which are still on the printer, because these ones are a little bit small, but the ones that I've just printed are there. So that's just some of the designs that we're going to be implementing over the next couple of weeks. One of the things that I was looking at, and if you look at the printer, let me switch back to this so that you can just see it's finished flashing the file to the SD card. It's now busy with the last piece, basically validating if the data was written to the drive correctly. So one thing that I noticed with the printer is if that's now, let's say you're looking at the printer from the back, and I put these rails vertically, which was going to be easier because I would put a bit long vertical rails, and then I'll be able to just quickly mount. But when I looked at this whole thing, I thought to myself, hold on a second, if that is now clipped on there, let me just clip it on, right, and that data is there, this power supply is quite heavy, right? And what's going to happen? We're going to have a slide. So hence why I've got 5 of these, and instead of putting them vertically, I'm now going to orientate my whole back of my printer with multiple DIN rails. Probably not the way I really wanted to do it, but I think it's going to look quite neat. I think it'll still fulfill what we need to do. And it'll give me that flexibility that I need. What else am I going to do on this printer while I'm waiting for that validation? So I think I mentioned at a stage, for the heated bed, I bought 2 heated beds, not just the 500 by 500 by 500, but I also bought the 300 by 300 heater bed. Simply because to heat up that big plate takes a lot of time. It's using 1500 watts versus 500 watts on the 300 by 300. And I think I can build a modification to that printer where I can have both beds. You know, I can remove the 500 and then I can put 300. Now, in order to do that, I've got to make sure that I can connect the heater bed and the thermistor that's inside the heater bed. So shopped around and I found this connector. Let me show you, maybe I am, right. According to the guys, this can handle 220 volts on 15 to 20 amps. So it seemed like it's quite a good solution because I'm going to connect all my wires inside there, put that, and I'm actually going to mount this portion to one of the arms, and each one of my beds will have this, and I basically just need to push it in and screw it on, and it shouldn't come loose, right? I'm going to try that. I'm hoping that these are strong enough to handle the voltage and the amperage. As far as I can read, it's good. We'll see. I've got some other connectors I could use. I know they're much higher amperages, but the problem is they're not going to sit as well as this one. This one's really going to make it easy. So my second bed, I will just have another connector. That is to come. Let's see how it goes. All right, so card is flashed, right? And we're now going to go back to, we're going to close this app. And before I close the app, let me just go back to the browser. Now I'm trying to see which browser I need to go to. Let's see if we go to that one and we close this. Somehow that screen has moved, but it's okay. We'll reposition that quickly so that you can see what I'm doing. Maybe just shrink it a little bit again. That's what happens when you move things around. You lose the aspect. All right, so that was back onto this page. We downloaded the firmware. We then downloaded this firmware software, the card writer to write the image to the SD card. And we're now going to put the SD card inside the Raspberry Pi. And the theory is that, and I haven't tested this, so it's just news. First time I'm also going to see this. It better work, otherwise you're going to be watching me problem solve for the next 2 hours. We're going to put the SD card in, and once it's after a few minutes of the Raspberry Pi starting up, there should be a hotspot called RatOS. Now we need to connect to that hotspot with our phone or our PC, and we're going to try and connect to it from the computer or maybe from my phone. We'll see how it goes. We'll have a look which way works best, and then we're going to go to this URL, or we're going to go to this IP directly, and we're going to try and connect to the actual RatOS deployment on the Raspberry. So let's do that. First of all, I'm just going to eject the card. Okay, it's already marked as ejected, so I can just pull it out, and on the back of the Raspberry Pi I can just slot that in. Probably help if I push it the right way. Okay, so SD card is in, and we're now going to, let's move this out of the way for a second. We're going to put that over there. Where's the power side? That's the power. So let's put the power there, and hopefully nobody's going to send me 20 messages while I'm using my phone. And I'm going to put my phone here, and we're going to see if we can connect to the software. Now maybe I'll do it like that just for initial, and we can turn it in a minute. Power into the Raspberry Pi. And I've switched the Raspberry Pi on. As you can see, the little lights are coming on. And now we're just going to give it a minute or two. And what I'm going to do on my phone is go to the Wi-Fi. Alright, so you're going to unfortunately have to see my home Wi-Fi name, but that's fine. You can't do much with the Wi-Fi name if you don't have the password. Let's go like that. That way you should be able to see the phone a little bit better. Now, I was told that it can take a little while. And there we go. RatOS is available. I'm not going to do it on my phone, so what I'm going to try and do is on the computer connect to that Wi-Fi, and hopefully I don't destroy the stream. And then I'm going to open up that link on the screen so that you can see it better. So let me see if I can connect to. Now my PC is connected to the network with a network cable. So in theory, if I connect to that Wi-Fi point, it shouldn't break my internet connection. It should keep the default route and then allow me to access that Raspberry Pi as well. So let's see. Password will be Raspberry. So if we come back to the screen, you'll see the password over here is Raspberry. Okay, in the middle, let me just highlight it there. That's RASP, not Raspberry. Okay. Right, so I'm gonna see if I can connect to RatOS. And I'm gonna connect. And I'm gonna type in the password. It's all lowercase. Unfortunately, you can't see what I'm doing now. For the next session, I'll try and actually have a whole screen share somehow. Some other reason I'm working on an Intel NUC and it doesn't want to allow me to connect a second screen, which is really funny. Okay, let's remove my phone from the view. It's now trying to connect to that. It has now connected to that RatOS and it will say no internet secured. Obviously there's no internet on this Raspberry Pi, so it's just doing a normal connection. What we're now going to do is I'm going to come back to this screen and I'm actually going to try and use this link and see if that works. There we go. Yeah, this is testing they say they never test the live demo Murphy when it comes to live demos. Well, so far I've tested him and he's okay. Mustn't talk too soon, but so far so good. All right, so immediately it comes up and it says, just going back to this document, it pretty much says to you just follow the steps that are there, and when you're finished you can. Now I could have connected the Pi directly to the Ethernet and done the same thing, but I wanted to do it with the Wi-Fi because I think most people will do it via the Wi-Fi connection. What it's asking is pick an access point to join. So it wants to know what. Oh, that's not nice. It wants to know which. What is your Wi-Fi at home that you want to connect to. So I'm going to refresh this. Let's see if it'll bring me back to where I was. I'm still connected, yes. Yeah, for some other reason it looks like it was. So I'm going to take the strongest one over here on the 5 gigahertz frequency, because that is the better connection for me to connect to in my house. I'm now going to type in my password and let's see if it is. It's not visible. That I can't let you know. And I'm going to save the credentials. All right. It's now going to ask me. Let's just close all of that down. It's now going to ask me, what do I want to call the host name? And this is RatOS. I'm just going to call this RatOS dash V-Core 500. That's just if I ever buy another printer, hopefully it won't be another 500, it'll be much smaller. Okay, to save and connect. Failed to fetch. That's very interesting. Okay. Let's just do RatRig. Let's see if that works like that. Failed to fetch. Alright, so we're definitely having some form of issue. Don't know if it can't be too long. Let's see if we shorten it slightly. Doubt it. Okay, let's go back. It seems to be losing Wi-Fi connectivity. Let's just give it a chance again and see if it'll come back. It's not very good, and I'm not quite sure why it's doing this. I'd like to get it done like this. Yeah, I could skip it and then I can go and plug it onto Ethernet cable and get it done in a different way. And I can do the Wi-Fi connection later, but I prefer to do it now if we can. So let's refresh this page and see if we can go again. What I could possibly do is rather open up the IP and see if that's a little bit more stable. Am I still connected? Let me check. Oh, I'm no longer connected to RatOS. So let me connect again. Okay. Somehow I've lost the connection there. Alright, so let's try and go before it does that again. Okay. Save, and let's just go with the short name here. Oh no, not RatRig. RatRig 500. Okay, save. Please don't. Please don't. It's now set up. To connect, your Raspberry Pi will now reboot and join your local network. Click on the button below to reboot the Pi and close this window. You can then connect to your local network where the RatRig 500 should be there. Okay, so let's grab that. I'm just going to copy that. Okay, so if it does fail, it's going to come back to the RatOS hotspot. So I'm going to give it time. The lights are definitely flashing on the back side here. I can show you. I'll just put it like that for now. Come here. You can stand there. You guys can see there's some lights and activity. I'm going to, on the side here, open up my phone and check that RatOS doesn't come back for some reason. Probably at a later stage I'll move this. I have a separate IoT network in my house that's very secure, so that anything that's coming in, any incoming connection from IoT device doesn't have access to the rest of the house. I plan to connect this to Octo Everywhere. With it connected to Octo Everywhere, maybe it would be good for me to move it to my IoT network, but that's something for later. Okay, it's still flashing quite a bit over there, but I think we've given it a little while, so let's go here and let's paste that URL. It seems to be working nicely. Right, and there you have it. This is the main cell interface, right? Obviously a little bit more green because RatOS has now put their skin over this, and they've changed a couple of things, and they've started installing a couple of items on here. So in theory, to have got here, hi Nishram, yeah, thank you. Enjoy. Definitely will have fun. To get to this point, doing it the old method of installing Debian and then doing all this would probably take me a good 2-3 hours to get it all up to this point, and that wouldn't be without some challenges. That's where RatOS just really stands out for me at this point in time. It's so easy to get to this point, and pretty much as long as nothing goes wrong, it's easy to get there, right? And that's pretty much the purpose of the RatOS, is to make this process as simple as possible. Now, if we now go back to the documents, you can see after completing the wizard, you can open up the browser and you can complete the wizard to flash your board, your controller board, and optionally your tool board. When you're done with that successfully, configuration will lead you to main cell, which you can then use update RatOS and do the updates. They also explain a little bit more about main cell and the interface that you're going to be using, and they explain a little bit about updating. Now we won't cover that now because it doesn't really make sense to cover it now, but I'll show you inside the interface. Once you finish with that, you can then go to your configuration guide and start wiring. What we're going to do now is I'm actually going to try and do the board flashing on while it's still here, and I'm also going to flash the tool board, the little tool board that I'm going to be using. This is a Big Tree Tech EBB42 board. So basically, one of these drivers on the main board sits inside here, and your fans and your controllers and your thermometers and everything is built into this little board, and this is the little board that I've made space for on the actual extruder. And I'm going to pretty much run power to here and one USB cable, and that's it. I don't have to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 15 cables, I think, 15 wires to the main board. I just need to do those few boards, and but this being a board is essentially same as this is a full controller board. This is also a full controller board, so it needs to get Clipper installed on it. Okay. So let's go back to over here, and we're now going to have a look at some of these. But before I do that, I now need to start connecting up the actual board, the controller board. So I'm trying to think what of the next steps. I just want to see that's fine. Crow's Nest, we're not worried about that for now. Beacon support, okay. That's notifications, print, upload. Okay, so I think pretty much we're going to use this install V-Core3 config. I'm not sure how we're going to do the tool board from here. I don't know if the toolboard is there. If we go to the machine side, this is where we were talking about we need to set up some files, specifically the printer CFG file. And this is the update manager that he was talking about in that page. Now you can see there's quite a few components already installed, and it's very tempting just to hit the update all components, but what they recommend is lots of these components can have a dependency on the RatOS. So we'll just update the RatOS on its own first. It's as simple as clicking a button. It's going to connect to the internet, connect to GitHub, and download the latest RatOS configuration. When you get back, close, and there you can see up to date. That's how simple it is to update these items. Before I do any flashing of the main boards, I'm going to now let it run and update the rest of these items, because I want to make sure that when we do push any firmware, we're pushing the latest firmware to the actual control board. So here it goes. This normally doesn't take very long. It's pretty quick normally, and you don't have to do updates. If you feel you don't want to do updates and there's nothing broken on your machine, then you continue. Obviously, the Clipper community, the mainsail community, the Moonrakers and all that, they're constantly updating and bringing out new features and fixing little bugs. So I tend to keep up to date. I run the updates. Yes, you could have a situation where an update actually breaks the machine. You could roll back if you wanted. A little bit harder to roll back, but some of the setups that we use in the config also become outdated. So sometimes you'll run an update and it will then say to you, listen, now that you've implemented this update, this feature and this feature and this feature have been superseded by this feature, and then you have to go and update those features. So again, they try and make it as automated as possible, but sometimes you do need to jump in and do some manual configuration. Over here you can see it's trying to flash the MCUs, right? Because part of the update now, if there is a MCU main controller unit update, it will try and include flashing that board directly if it has a boot zone, some other boot zone. I can't remember exactly the right terminology, but it can actually update the board on the fly. I haven't got it connected, so obviously I couldn't update it or run, but it's because I'm going to deploy to the board once everything is up and running. This happens because as it's going through updates, it's restarting different components. When it's finished, the close button is there. We can click close. It will probably likely restart Clipper, Moonraker, and then you can see we're up to date. Now, lately I've seen this button here as well. If you click on that, repo has been untracked from sources. It gives you additional information on certain things that have changed there. And if there's any concerns. Now, I don't quite fully understand what it means to untracked source files. I think it might have stopped using these files, or there's a conflict of version. I'm not quite sure myself. But for now, we're not really going to worry about that. If we have issues, then we can get back to seeing why. All right, so we're up to date. Should be nothing really in the history. Here's where we can view some of the code. We can view the files we want to print. These will be the G-code files that you printed, all the printals. This is the console where you can actually send commands manually, and then naturally we get back to the dashboard. So let's move away from that for a little while, and we're now going to connect, and it just doesn't matter interest. This heatsink, you can feel the heat coming off it. It's not hot, but there's heat, and that's why I want to put the heatsink on. I prefer to have the heatsink on top of the Raspberry Pi. What I want to do is I want to now connect my power to my power supply. I want to connect my power supply to my main MCU board, and my MCU I want to connect to my Raspberry Pi, and then we're going to try and flash the board. Now, you don't need, as far as I'm concerned, you don't need your drivers in. The drivers only enable if they're there, but I'll just leave that one in, and we're going to try and flash it from inside the software. Let's take into account that when we're flashing this board, that it's not exactly the board that was intended to be put in here, so it might work and it might not work. You can't really damage it as far as I know, flashing it. I don't think there's anything you can push over there. If it doesn't understand the software, it's just not going to work. So we're going to try it and see how that goes. So first of all, on the side, before we got to the session, I prepared some cables. So let's connect these. Let me bring the side camera in and do it like that. On your power supply, just so we can have clarity, you've got your AC side, your live, neutral, and your earth. And then this is a 24-volt power supply, so we've got 3 negative terminals and 3 positive terminals, right? All giving 24 volts. So let's open up this one and loosen this. Now I decided just to put round lugs on. Normally I put spade lugs on. I just decided tonight to do it the other way around because we're going to be moving the cables around. I thought, well, if it does want to come pull out or something like that while I'm moving it, probably easier just to do it this way. This is not the cable that I'll be using inside the printer itself. This is just a temporary solution. Yeah, Mr. France, go big or go home. Yeah. I can tell you I've watched many streams where it didn't go right. But I will also say, lots of the times that the people do stream these things, they don't read. And that's one of the big reasons why they fail many times, because they miss the finer details. And they try and use what they did 10 years ago, right? And that bites them at a stage. Okay, so live, neutral, and earth. Right. Plug was already done. So I assume by you doing this, you know how to work with 220 volt AC or 110 volt AC, wherever you're positioned, situated in the world. Also, please remember that when you get your power supply, it's a little bit close now, but there's a switch inside there and you need to make sure it's on the right voltage. If it's on 110 and you plug it into 230, you will let the smoke pixies come out of this box. If it's on 230 and you plug it into 110, well, you probably just have nothing much happen. Okay. Right, so I'm now going to move that to about there. Pull the plug around to the side, and I'm going to plug it into one of these plugs over here on the side on the wall. Let's see if I just run it this way, I can get to that plug easy enough. Right. And I'm just trying to position myself in the camera. I'm really battling to find my place. Okay, so I'm going to switch on it first, make sure that everything's looking fine. Power's on, and if you have your multimeter, you can then test and make sure you've got 24 volts. I used this power supply earlier today. I know there's 24 volts coming through over there nice and clean. Okay, switching off again. I'm using a cable from one of my previous builds, pretty much just a short little lead, and I'm going to take the negative wire and tighten it on there. And my positive wire, I'm going to plug in on that there. Just do me a favor, make sure your other terminals are in general tightened down. I removed this today because I was using it somewhere else and I didn't tighten them. Just tighten them down, don't let them move around and vibrate and come out, because the printer does have vibrations. Just a good habit to keep them tight. Right, on the printer, on the MCU, we've got motor power, we've got normal power, we've got bed power, right, and we've got bed out. So one thing to notice here, we're going to be putting the power to the actual board. This power is for this board. Motor power, you can bring in an additional power supply up to 60, I think it's up to 64 volts or something like that. So if you're running high voltage stepper drivers, the 5160s I think, and you're running high voltage motors and you need the higher voltage, you can bring in whatever voltage you need. I think it's up to 64 volts. I talk under correction. Your bed power, same over there. If you've got a 12 volt bed, you can put 12 volts there. If you've got a 24 volt bed, you can put 24 volts there, right? Whatever needs to go to your bed, you put over there. We're not running AC through this, okay? This is for DC only, right? As far as I'm concerned, you cannot do AC over there. And you don't want to really, because it'll pull whatever over here is too hard. I don't think there's enough. It's not as good as a solid state relay that will handle the power. Then bed out is the actual power that goes to the bed, right? Because motor will get its power through the connectors on the side of here, where bed out will be the connectors that actually go to the bed itself. And we're going to connect this later on to our SSR. Just take note, one thing, I don't know why they did it, but it's negative, positive, negative, positive, negative, positive, and then they swap around and do positive, negative. Got no idea why they did it that way around, but just please note polarity on DC is very, very important. So we're going to swap these two wires over, and we're going to, I'm just going to move a little bit this way so that I can get my screwdriver underneath the camera. Power there. Okay, and Let's do that like that. Make it work a little bit to the side. Yes, I am twisting the wires over. It's because the lugs were built on a different board, the other way around. And I don't like putting the lug upside down for some other reason. Yeah, and lots of people are saying, yeah, but why didn't you get black lugs and red lugs? Well, you don't. You get red lugs, which is one size, and you get blue lugs, which is another size. And I didn't see that when I was busy initially doing this. I only noticed it later. That's why you'll see on this side, you've got all the same color lugs because it depends on the wire thickness. So the colors are based on determine the wire. You can buy kits like this, right? And they've got a variety, and the yellow and the blue and the reds all have different sizes. Okay. All right. I'm now going to need a USB cable, and I'm just thinking to myself for a moment. Do I connect it on the USB-C or do I connect it on that one over there? I'm not quite sure. So there's two USB ports, and I'm not quite sure what's the difference in the two USB ports. So let me quickly go to a browser and go BTT Octopus Emacs Max EZ. Let's do the manual. While I'm there, I can download this. Let's open up this manual. Yeah, download. Okay, so now let me bring up this over here, and you can see the manual, and I'm just gonna flip through this quickly because I want to have a look why that board. So that driver input, where was the voltage? 224. Battery text, heated bed. So the heated input voltage can only be 12 volts or 24 volts, right? That was the one thing I said. So I said you wouldn't be able to connect AC to it. I wasn't 100% sure, but it was there. Those are the different drivers that you can put in, and there's the 5160, which can handle the higher voltage motors. And this is where I want to be. This is a 5 volt out connector. It's not actually a USB connector. Voltage out. Okay, so we're definitely going to connect to that. So let me grab a cable, which was lying, not coincidentally, but purposely, very close. As I can say, this is where lots of people decide, no, you know what, this is not for me. This gets too tricky, and then they're not interested in doing their printers anymore. Okay, put that up slightly. Right, put that over there. Raspberry Pi. And chuck it over there. Move the screwdriver out of the way. And I'm going to connect it to one of the USB 3 ports. Okay. And in theory, we can now switch on the power supply. I'm just redirecting my wires. So negative goes to negative, positive going to positive. That's fine, that's fine. Right, let's switch on. Okay, well, we've got one little light down, the light indicators down this side. I'm not sure if you're really going to see the lights there. If I do that, you can see there's a light on this corner there, shows 12 volt. Active. Right. No strange smoke coming out. So far we're good. I think we can now go back to this screen. And I would have wanted to now connect to the SSH terminal and check what's going on, and is it all connected, and has it seen the board, but let's just do it as if someone else was doing it and didn't know about this before. So install V-Core3 config. So let's click on that and see what it does. Okay, so this is where I think there's supposed to be some form of wizard that runs and does the rest of the setup. So I just want to go back one step. I want to have a look at that there, configure. I want that there. Let's see. If we go, yeah. Okay. Thought we missed something. So, as I said, many people don't read the documentation correctly. After putting the SD card in and running that initial where we got RatHost and we got a configuration, and then we selected the Wi-Fi, and we then let it reboot and it connected to the house Wi-Fi. What they actually serve here is, after completing the Wi-Fi, said wait a couple of minutes, then open this. So the URL that I copied wasn't this copied. Now, because I changed the name to RatRig 500, I just needed to rename that piece and then use the rest of this URL. So you can see over there, RatRig 500.local, configure step 1. And this is where it's actually going to now take us through the next steps, which I'm very happy to see. Over here, we're going to choose I'm not sure which one of these I'm going to be choosing. Let's just go back to this. I wanted to go and have a look at where they show the supported boards. Okay, so on this they say 1.0 and then 1.1. So I'm probably going to go with the latest one, which is 1.1. Coming back here, even though they don't say 1.0, I would assume that we're going to do this one over here. It's the SKR3, SKR. Let's just double check that we haven't Octopus Pro. Yeah, so the Octopus Pro or the Octopus Max EZ board is not here yet. So we're just going to use this one here when in doubt. Next. Right, how do you want to flash the Octopus? I can do it flash manually via the DFU, flash manually via SD card. So what you can do is you can have a SD card, a little SD card, right? And you can put that into your machine and you can have the firmware written to that. You then put it inside the board. You switch off the board first, put it in, switch it on, give it a couple of seconds, it then uploads the new firmware, and then automatically it is upgraded to the latest firmware. But I would like to try this flash manually via DFU and see what it does. If not, we'll come back to flash manually via SD card. Okay, so on the Octopus Pro, we need to set status DFU not detected, right? Waiting for DFU. So what we need to do is we need to connect the board via USB, add the jumper to boot 0 as shown in the picture, and make sure the board is powered on. If the board is already connected and powered, when you insert the jumper, click the reset button on the board. Okay. Naturally this board is now slightly different, so I need to see if I can see a reset button. I don't see a reset button, to be honest with you. Oh, there's 3 buttons in the middle, yeah? And then I will need to figure out which is the boot. So we're looking for the boot 0 connector. So I'm now going to go back to, and we're going to quickly understand if we can see the boot 0 connector to put it into DFU mode. Now it should be further down in the document if I don't see it here. Okay. There's a lot of information, I know, but just going to scan through it quickly, see if I see anything. Yeah, Mr. France, lots and lots of info here. This is where the streams get a bit boring sometimes for most people because, you know, can we see some action? It's not like when you're building the printer, everybody's at least seeing things happen the whole time. Okay, I don't see anything there. Alright. USB is a power supply. UART, TMC drivers, voltage selection, VR touch, water power, wiring, filament sensor, proximity switch, fans, and they go straight into the documentation. See if they got anywhere further down when we go past. This is all Marlin. We're not doing Marlin, we're doing Clipper. So as you can see, if we get down to the Clipper section, if they maybe mentioned it over here. So here's Clipper. This is the actual way of installing Clipper on the Raspberry Pi. You use the original Raspberry Pi installer, and you can choose a custom, and then you can write whatever file to the SD card. So same method, just different software. You could do the RatOS in the same way. This is still the Raspberry Pi being set up. Compile firmware. This is where you actually set the firmware. I should actually maybe compare this to the other board. I'll probably do that after the stream tonight, just to see if there was any difference. If we get it right. If we don't get it right, then we're probably going to have to try and fix it. Configure Clipper. Okay, they don't mention how to do it with DFU mode. And I will, sometimes if you just go to the browser, you can say BTT Octopus. Let's take that and DFU mode. Let's see if it's anything like that. I think this is exactly the same. Let's just say DFU mode on its own. Let's just have a quick look. I don't want to browse too much around, and if I don't see it in the next minute or so, then we'll move on. What's not nice is they haven't given what the buttons are for. In the manual, there was nothing about the buttons, which is actually strange. Let's look at that. So boot 0 and boot 1. So maybe if I push the middle button, I can get it into DFU mode. So I'm just going to click it once. All right. And then I'm going to come back. Where were we? Oh my goodness, I've lost. Yeah. Let's go back. Try again. not detected. I don't seem to know how to get it into DFU mode, although the button's there for boot 0. I don't see, I just don't, there could be a jump over here that I'm missing. Let's go to the next diagram, just make sure again. See boot 0. There is a little LED there. Okay, it's probably not going to work where we wanted to do it. Just using the other one. Very sad that the documentation is always so poor on some of these things. They could really the onboard boot button to enable the talks about the button. Yes, and that's it. That's the full extent of what they're going to give you. I'm just going to go back here. Let's go to firmware, clipper. That's just a configuration file. So they've given us no way to actually say how do we get the board into DFU mode, and that's the DFU mode is what is used to actually enable us to push the firmware directly. Just going to jump into this document and see what makes a difference. I know I'm not supposed to be showing content of other stuff, so let me just give me a moment. I'm just going to switch to this camera view. Not supposed to be showing other people's content on the internet, and I do want to respect that on your stream, that you're not supposed to be doing that. Unless it's a public user manual, and I don't always know when I'm clicking on a link where I'm going to go in. I'm just going to put my hand over this thing here. There's no indicator that it actually says that it's doing something to move into DFU mode. So if one of you want to Google and see how do I get Octopus EZ, Max EZ into DFU mode, you're welcome to have a quick look and drop me a message in the chat. Help me a little bit out. Let's see if we can get it there. Try something like looking. I am focusing very hard. If you see pixie dust, it's not coming out of the board, it's coming out of my brains, man. I'm trying to figure out why I can't go into DFU mode. I'm wondering, just as a matter of interest, I'm going to switch off the power and I'm going to put the SD card in. Not that I think it makes a difference. Just in case the DFU mode wants to use a card while in the board. Go back to the RatOS. Come, Mr. France, you're good at searching the internet. Oh, Mr. Cat, you're gonna stand on my keyboard. No. He's not happy with me. Plug. So you would think you would just click it and it would automatically go into DFU mode. So that it could, I wonder if it could be that it doesn't recognize the board. Could be that it's not recognizing the board. That's why it doesn't want to, the board might be in DFU mode, but it's not recognizing the chipset on the board, and therefore it doesn't want to go into DFU mode. Not sure. Okay, let's go with the other method. I will play with that around and see if I can figure a way how to do DFU mode on that board. But I don't see anything obvious hanging out. There's one last page specifically talking about it. Okay, no, I'm not interested in getting to that page. Right, let's close that, and we'll come back to that. So I'm just going to show you what I'm with on the screen at the moment. I'm going to go back. While I am going to select this one and say flash manually, I want to be careful when it's going to compile this firmware, right? Because when it compiles this firmware, is it going to compile it the same as this board? So I'm going to take this and I'm going to search for that there, and say manual. We're going to go here, which is the official website for this. This is the Pro. This is the pin layouts. And maybe I'll just go back one level here. I want to have a look. The pinouts are quite different on these. And see readme. These are the actual configs in the bin files, and we don't want to use their stuff. Build firmware image. Right, this is what I want to check. Okay, so you choose your model. Depends on those here. The offset or our H723. H723 boot offset is 128. Okay, coming to this document, right down at the bottom here, they had a section here. Alright, so what we're going to do is we're going to look at this. Obviously we're choosing that. It's the same. They're using the same offset and a 25 megahertz crystal. Clock reference for the 723 is 25. That's fine. If USB communication on USB, right? Else if you're not, okay. So the actual config, when we create the bin file, the actual firmware file will look the same between the two different versions of boards. So there should be no difference. That's why I feel it should actually get into a it should actually do the DFU. But okay, let's continue. I'm going to take the SD card and put it inside the SD card reader in the computer. There's one previous file there. I'm just going to drop that file. Again, this file, it should be less, preferably like, I think what they say, a FAT16 format. Oh, there it is. Yeah, FAT16 format. And if it's FAT32, then you use an 8-bit or a 4-bit kilobyte, and you can just format the board up front. Right, now we're going to compile the firmware. Now this normally we do directly inside the in the SSH sessions. I do this manually normally, and that's why this route is totally different. That's why I really want to use the RatOS way, just to see how easy it is, even though it takes me tonight extra time to get this through. Yeah, there is no jumper on this board, and the Octopus 1.1 versus the Octopus Max EZ are two different boards. They're totally different boards now. That's why I've got to try and find, because the normal Octopus doesn't have the boot buttons like this one does, where this one has actual boot buttons. I assume you're supposed to just click the button and it's supposed to go into DFU mode. But I'll read up a little bit further on that one. Okay, so it's now in the background, did all that settings, did all that, it made the file and it's actually confirmed it. Now you can download that file, which is fantastic in terms of this overall interface. You can't see what I'm seeing on the right hand side here. Now the file's actually downloaded. So let's go to the Explorer. Yeah, you can see I downloaded the file, and that file, firmware.bin. If we go back to we just need to go back to the documentation, and pretty much what they say is, once you if you're using card, yeah, copy the firmware onto the file SD card. Make sure the file is called firmware.bin. Yes, because normally when the file is compiled, it's called clipper.bin. So you've got to change it. safely eject, take it out physically, insert it into your control board, click on the reset button on your board, or turn it off and back on again. Note if the Raspberry Pi running RatOS is currently powered on by your, please shut down safely first. Okay. Alright. So this is where this is either going to work. So if I do this firmware upload now and it doesn't work, then this software is looking for some specific version. If it does work, well then great. We can continue this way. DFU upload can happen later on again. That's not serious. So I'm going to go back to the downloads folder here. I'm now going to copy this and I'm going to drop it into there. Right, go back to the downloads because I'm now going to eject this card safely. Right, eject. Right, you can see it's now been taken out, so pull that out, and it's off at the moment, so I'm just going to plug that in there. We can just come back to Chrome, and we're now going to switch on. The middle little light was very fast, but it flickered more than what it normally would. Yeah, it flickered quite a few times, and there you go. Octopus Pro 1 detected. So it detected. So somehow we're just not getting DFU mode right, but that's fine. We can move on without that. To proceed to the next step, see the next step or flash again. So we're going to go next. Pick your tool board. Now the tool board is this little board, right? I actually haven't got the tool board ready to be connected. So what I need to do is create the power plug for this little tool board. So we can do that now. Inside this little holder of goodies is the power connector. What I will do is, let's just come back here for a moment, and then I'm going to go and look for the board so that I can show you EBB42 manual. Let's download that one. Okay. With that, you can see the board better. So that's the little board, and I need to attach power and the USB. So unfortunately, it doesn't get power from the USB. I'd like to just double. Okay, let's go down further. First time I'm using this little board as well. I haven't used it before. Rebus. Okay, that's the CAN connector there. So we're just going to use power, and the power is on the lower two, positive and negative. Okay, so just so that you can see, not very well done. Let's see if they show it anywhere else. No, they don't. So one of the complaints I've read up is that these guys don't show the connection very well. And if you want to connect with power, so I'm just going to zoom in here. On this connector, the two top, if you look at the two top connectors, and I'm going to put it like that so that you can probably see just over there what I'm talking about. Let me just come to this camera, go in here and switch the focus onto auto. Right, maybe it'll focus there. Hold it still. Okay. So the top two wires, pieces go into the back. And if you look at the back over here, that's the high and the low on CAN bus. We're not going to be using the CAN bus. But if you look at the back, the smaller little connectors at the bottom, right, around down there, the positive and negative are at the back end. That's how you power this board. So I need to make sure that I take this out here. I need to take one of these plugs, one of these little plugs, and actually connect it up correct and crimp it with the wires inside there. I'm going to do that now. I just want to see what I have in terms of cables. I wish I had cable like that already built, that I didn't have to use it now, but that's okay. I'm going to figure out in terms of those connectors are for that, and those connectors are for that, and these ones are for, so these ones are for this. Okay. Just mind all these other screens I've got over here. Okay, so now I need to get long wire. I'm just going to have a quick browse through my cables that I have lying around here. Just make sure I don't have a cable similar to that already wired up, which doesn't seem to be the case. Okay, I don't have, and I need to now create one. I just want to see what size wire I'm going to be using. Let's use the thicker gauge wire. I've now got to take into consideration that this wire that I'm building up will have to be at least the length of what the printer will, when the printer heads all the way to the front, it goes through a wire, through a loom, and down to the bottom of the printer. So I'm going to measure on the printer and actually roll the right length of wire out now, so that I can make sure I don't waste the connector and the wire. So just give me a moment while I do that. I can actually show you how I'm going to do it up there. Okay, so I've got to consider that this head of this printer will go all the way to the front and to the furthest point, right? And then this wire is going to go connect there. It's going to go up, run in through like a loom running over there, then come down. It'll come to the main power supply sitting somewhere down there. So what I'm going to do is I'm going to take that length and I'm just going to give myself rather too long than too short. Just give myself another set of wire that long, and I'm going to cut that. Okay. I'm going to do the same for a red wire. Just put these two together. Probably much longer than what it needs to be, but it's okay. I'd rather have too long than have to join a cable. I really don't want to join a cable later on. And the wire won't go to waste. There'll be lots of shorter runs that I need. Little pieces at some point in time. Okay. Driving the cat crazy down the bottom here. Roll that up like that for now. Oh, and then you get to see me crimping a wire as well tonight. How about that? No, we want to focus on, yeah, why am I going? Okay. So let me get my two different crimps and my wire stripper. And I need this crimp. Now I'm not going to show you how to do crimping. If you want to see how to do crimping, there's lots of videos on the internet. Just go and have a look. You'll find them. And there's different types of crimp, so each one you need to figure out for yourself how is the best crimp type. I just want to check the length of what I'm going to do. Like that. Maybe one click slow. Right. And I'll keep the camera sort of there. This camera seems to lose its focus a lot. I'm not very happy about the autofocus on these things, but that's what you do. What happens when you're just using standard webcams that weren't really intended for streaming like this, but we're making it happen on the budget that we have. Okay. Right, now I'm going to put that in there. Come on. Let's turn this a little bit like that, and I can, while you see what I'm doing, I can also see. Right. Let's see if we can push that in. No. Okay. This wire's a little bit thicker than what I normally use, because I want to try use a thicker gauge just to make sure, because I plan to put a high flow hot end on the front of this printer. And because I'm going to use the high flow, I'm going to use a 60 watt heater in the front, which is quite a bit more power required, and obviously will draw quite a bit more amperage and wattage through the cable. Yeah, that connector feels a little bit too long. This wire is a bit too long. Let's take this. And shorten that. You don't want the wires to go inside the connector where the actual pin is pushing through, because sometimes you actually make it very difficult for yourself to get that connector in and out, because the wires are pushing over the pins and funny little things like that. But this is just, you know, by experience, you figure out what works best for you. Just checking it on this side. Yeah, I don't want to squeeze that there. Nice. I will tell you, it's not a hobby that I want to do. It's crimping. It takes forever. I'd much rather avoid it if I could. Okay, so if I've done it correctly, that should be okay. I just want to push this one in a little bit deeper. It feels like I'm missing that connector. That's better. Let's just go back one more time on this one. About there. Yeah, that's better. Okay. And on this connector, just going to double check. I wish I could show you the crimping properly, but I don't think the camera would. Yeah, well, there you go. Not bad. I've crimped a few cables. Right, so now I'm going to check negatives on that side. So I need it in there. Okay. And this little plug. I'm not sure which way it should go in. Let's try both ways first. That way works better. Double check myself again. The black is on the bottom, on the right hand side of that, yes. Okay. Can't tell you how many connectors I've made. Only to have to come back and fix them again. Alright. So that's going to go in there. Right. And my 600 meters of cable on the opposite ends. I'm then going to put in, I'll just put some of these lugs on that I've got for now. I'll just use exactly the same lug. I'm not going. I don't really want to. Just push it with the wires in for now. Although I could probably just push the wires in. Yeah, I think I'll just push the wire in for now. So let me make it just a little bit longer when I strip it, like that. Seeing as though it's only 12 volts, 24 volts, it should be okay. I'm going to switch this board off now because I'm going to attach these wires to the power supply. Okay. I assume that when I do that, this thing ain't gonna moan. Let's see what it does. Okay. There, the power went off. Let's take the screwdriver and plug it in on the negative. Well, now this should work fine. Okay. Now we can power that up. Let's move the metal Allen key out the way, and then wait for no pixie smoke. We've got little lights. Very difficult for you to see, but we've got a green and a blue light that have come on. Okay. So now I'm going to take another USB cable. I'm just going to take this wires and throw them on this side of the table for a little while, just so they're out of my way. Let them get up, pull on it while I'm busy. There we go. Okay, you should still be able to see roughly what I'm doing. Okay, on that I'm now going to plug in the USB, and I'm going to plug the USB into the bottom of the Raspberry Pi over there. Okay, move all of this to the side. I'll put it back into the plastic bag a little bit later. Okay, get that out of the way. Move those out of the way. Right. So on this page, I'm using. Let's see if it's written on the board anywhere. Yes, so you can read. I don't know if you're going to be able to read it. EVB 42 CAN version 1 V1.2. Okay, so you get a 36, which is a different shape. Same thing, just a different shape. Then you get a 42 and the 1.2. Right, so we're going to choose that one. And flash manually via DFU. Okay, connect the board to the USB power, right? Make sure the board is powered. You can use USB power by placing jump on the V bus. Okay, we're not going to do that. We've already got power on it. Press and hold the boot button on the board. Press and hold the boot button on the board. press the reset and press and release the reset button on the board. Release the boot button. Okay. Right. That's the reset and that's the boot. Okay. Alright, so now you move this a little bit this way. I'm going to try and do it with the Allen key and stuff so that you can sort of see what I'm doing. Not normally pushing the screwdrivers in there, but we're going to push and hold the boot button, and we're going to push and release the reset button. Okay, and then we will release the boot button. Okay, there you are, DFU detected, and that was how the other board was supposed to do it. Now I might think that we should have just followed the same principle because they come from the same manufacturer. Interesting. I might even try it later offline and just come back to you next week and tell you if it worked the same. Right, so let's flash. It's like animals all over. Dog underneath the table, cat in the box. I put a big holder down with a blanket in so that the cat would, you know, go there. All right, so EBB has been flashed. That's awesome news. Next. Right, now that your control board is configured, you can connect to your printer via main cell and start configuring and calibrating your printer. You can now continue to the next step of the documentation. All right, and that will just take us to main cell. Right, now you're still most likely going to get errors. Let's see what this does. Just push it once and see if it does something. I would have thought we would have seen more. Simply because everything's online. Come on. Come on, come on. Maybe I should do a switch off and restart. Let's switch off. Okay, I've just switched off this. The main MCU and the EBB MCU, just so that they both reset. Just want to see if that makes a difference. We're definitely supposed to see something better than that. go here and have a look. I want to see in the printer CFG that it actually write so give me a moment here. I just want to have a look. These guys, this is the first time I'm seeing this code again, but somewhere in the early section we should see a MCU configuration. Okay. Okay, so I think there's obviously a couple of things that need to be done now in this file, and actually play around and change some of the settings. I would have hoped to have seen at least to give us this error saying, you know, the boards are started, but it can't detect some of the other stuff. But definitely, like over here, that's not right. So if I go back to, let's just close this, don't save, and I come, see there, and it is unable to quick connect and restart. Okay, so if I come back to the dashboard over here, the wizard's gone that we had earlier. And I think that's because I did something earlier, maybe. So it would be interesting to have seen it from the scratch. And I would have thought the macros would have been here now to actually set up this board. So because of that, I'm going to have to maybe do some of this work manually myself. And one of those settings are definitely, I need to comment out that board, because we're not using that one. We're definitely using something closer to this board, but I don't think and these two boards work. These two only work with BTT. Okay, so, you know, most likely that one as well. So let's just have a quick change and see if that does anything. Yeah, so what's going to happen now is it's sort of already saying there's a problem with the pin configuration. I understand this pin configuration is different to the other board. So what I'm going to have to now do is actually sit down and go through the actual pin configuration and compare it to the documentation step for step, and see where the differences are. Now, I'm not going to let you sit and watch that, because hopefully if you're going to build this or are building this setup, by that time either this board is supported or you've actually bought the board that is supported, right? Unlike me, that wants to always do something different, and that, you know, that this will work. I think, just for interest's sake, I just wanted to try, if I comment that out, it might give me a different error. Yeah, it is definitely that which is causing a bit of a challenge. It's the configuration at this point in time. So I think I'm going to call it a night with the stream. There's not something I really want to describe, but I think just see this as the importance of, before you attach all of this inside your printer, I really think it's better to sit down on a table, have this all laid out, test it to as much as you can, and see if you can get to the point where you can actually get the board to work. Remember, you don't need the devices plugged in for it to actually operate at this point in time. All you need is for the board's firmware to register and the board to come up, and that I'll show you as I go along next week. So yeah, thanks for joining. We are streaming tomorrow night again, and I'm sure by that time I'll have a lot more to show you in terms of this specific board, how it differed and how I got it up and running, and then we will start looking at maybe placing some of the stuff on the actual printer, placement and getting things done, and start looking at where the wiring is going to go and how the wiring will look. I've got the RatRig wiring looms over here, and I must say I think a lot of the wiring I probably have to redo, but the basic wires are there, so I will just have to see how it goes in terms of what to connect and where to do some changes. I might, Mr. France might even join me tomorrow night, because we will have to pick this machine up and move it around a little bit. So yeah, thanks for that. Good lesson in terms of what we're doing, and so far I'm actually quite impressed with the Rat OS. You saw we got reasonably far without having too many hassles. Had I had the original board, it would have been a lot easier, right? Had I not the original board, I had one of the supported boards, I think it would have just gone very smoothly. But for now, that's all for now, and see you tomorrow night again, and have a good evening. Cheers.